everybody. This is Nicholas McMillen with OWETEC Services. Hope everybody's having a good time. Glad to have everybody here and with us. So what we're going to do is we're going to go through the different steps and procedures that it takes to get to the orbital welding. As we know, the first step with orbital welding, or if you don't know, we always have to start with cutting, preparation, and facing of the tubing to get that nice square groove butt joint in order to complete that orbital weld, because there's things that we're worried about like ID and OD burrs and misalignments of the square groove butt joint. So it comes in many different sizes and ranges. The one I have here goes from 1/4 inch to 4.5 inches diameter. So the first tube that we're going to start with that we're going to cut is our 1/2 inch 065 wall stainless steel 316L tubing. Just one continuous motion. Engage that, lock it in. Go ahead and feed. Come around, and we have a nice clean cut. So another thing, we have a cut, pretty good cut, very minimal burrs, but still not necessarily exactly where we need it for orbital welding process. So at this point, I'm going to go ahead and hand it off to Adrien, and he's going to do
now
some.
that we have our pieces of tube cut, important thing, especially when we are talking about semiconductor pharmaceutical industry, we always want to have our piece of tube as much clean as possible. So to do so, we are doing a facing in order to remove the outside and the inside burr. So moving backward, just clamping my tube, making sure I'm tight, and then just press, turn, makes it turn, makes my insert turning, and then just feed it. As you can see with my right hand right there, I'm feeding my insert into the tube. Okay. And by doing so, I now have a completely square and without burr tubing.
Hello, everybody. So now that we got the cutting and the facing preparation done, we have nice square groove butt joints that we can go ahead and place into our orbital weld head, where we can get a nice fit up and alignment set so that we can get a good welding or good weld in place. The weld schedule, I'm going to go to weld library. This is, by the way, the new SAX 201. Really nice interface, real smooth operation. So we'll go ahead and we'll hit add program. And it starts to ask for some basic information. So weld head, we're going to go ahead and pick our SAX SATFX 52 weld head, which we have in place here. Then we're going to go ahead and name our program. We'll go ahead and name it OWETEC. See, that's pretty fitting. Go ahead. Accessory, we'll talk about that a little bit. This is if you wanted to let the weld program know that you have like different offset electrodes. It won't necessarily change the weld schedule, but it's good for informational purposes depending on how you had to develop your weld schedule, or if again you needed those offset electrodes, mainly seen in like kind of pharmaceuticals where you have to clear those different radiuses or in different aerospace applications. But again, can be used for any application that you have. Diameter, we know this is going to be 1/2 inch. And wall thickness, 65 thousandths. You have different material types that you can pick from. So here I'm going to go ahead and select stainless steel. And here I'm going to add the grade. Now this won't change the weld schedule based on the grade type, but this is good for your informational purposes so you know what you're welding. So I'm doing 316L. And I'm going to go through. Here you have your different weld preps so you can pick. Now we know when we're talking about orbital fusion welding, we're going to be going with what's called a square groove butt joint. There's going to be no joint preparation, no beveling, no J prep, no U prep, no V groove. We're talking just purely square groove butt joint. But it can do wire feed processes too, where there might be a land or preparation on the tubing or pipe. This is where you would change that. You can name each part for informational purposes. So tubing 1 can be whatever you want to call it. It can be a heat number, a lot number, identification number, and then you can even add a drawing number too if you're working to a fabrication or installation to a fluid system or gas system of such. So pass, we can name it whatever we'd like, or they have some nice options here that are preset where it could be tube to tube, tube to ferrule, tube to microfit. Right now, we're doing tube to tube, so we'll go ahead and select tube to tube to name that. This CAN program that comes right from the SAX 201, it's going to have 11 levels. You can modify and adjust this, which we'll talk about, and when we get to 1/4 inch 035. For now, we're going to use the CAN program. And in the comment section, this is just be any notes or anything that you want to add to the weld schedule, being it show up on your flash drive or your printout or however you log that information. Here, it lets me know the tungsten size, diameter, length, the arc gap. General rule of thumb is the arc gap is going to be the wall thickness. So the distance between the work or the tube to the tungsten electrode will be that of the wall thickness. Again, that can change in the field or based on what your application is or what you're trying to achieve, which we provide in our training because that does change regularly on what we're trying to achieve as far as that bead profile width and penetration. So come here, again, it's for informational purposes, so I can pick the right electrode, which I'm going to do now as I'm looking at it. I'd love to say my memory was good enough to remember all of these off the top of my head, but it is not. So I go ahead and I verify that I have the correct electrode pack that it's calling for, which is nice because it's labeled on their packs that matches up to the machine. Also, you have different electrode types that you can choose from, meaning doping elements or alloying elements that are added to the tungsten based on performance. Normally in orbital welding, we are using electrodes that have cerium or lanthanated doping elements added to them. So we'll go ahead and exit out of that. Here is where we set up our gas flow, either for our OD shielding or our ID purge. We're going to be doing ID purge manually today and talking about some purge techniques. But here's where you set your shielding flow and it lets you know what that shielding flow is going to be. Also, you can change the different gas mixtures. We could talk about that a little later in a different webinar, when we would approach that, how it works with the SAX 201. But as you know, there are different gas mixtures sometimes based on penetration and weld profile that we need, that we can't just do with pure argon. So come through here. This is where it gets into some of what I call the meat and potatoes of the weld schedule development. You have your pre-gas, which is going to be before the welding, fills that weld head up with all that shielding gas to mitigate discoloration, to get all those particulates like moisture, oxygen, anything that can cause ID discoloration, which is very prevalent in stainless steel tubing that we have to worry about. So right now it's set to 30 seconds. A lot of people set it usually to 20. I call it 20 seconds of mercy. That's also another way of saying if there's anything in the weld schedule that I don't like, I have that 30 or 20 seconds to hit the stop button to readjust or reset myself. Arc strike, this is where the arc is going to start at, that it's going to upslope to, which we'll talk about that here in a minute. But that's going to be our initial amperage to start that puddle formation. Preheating here, another way to think of preheating is like a rotor delay or arc delay that sits there and allows it to delay at 39.8 amps for 3.3 seconds to get that puddle to form so that it matches the rest of the weld profile. So that we don't have any of that meandering or snaking going on. And then upslope is its way of upsloping that arc or that voltage to that amperage that we're asking for, just to promote like electrolyte. So here it lets us know our different levels and the degrees at which each level ends at. So kind of keep this high level for now. We'll get a little more into it as we get into the 1/4 inch. Here it lets us know our amperage, meaning our high amps and our low amps, or as some folks might know it as our primary amps and our background amps for each level, because this is a rapid dynamic response pulsing system that we're using. And then we have our pulses per second. So here we can go through each one of the different levels. There's a quicker way to do it, which we'll show here shortly. Then we go into our overlap, which is our tie-in from that last level to our first level. And then we have our downslope. Downslope is always important because we don't want to just break that arc right after the welding operation. We want to be able to trickle down on that amperage, just like they do in manual welding, because you don't want any crater cracks or crater holes or any craters in general. So you want to have that nice smooth transition of the arc trailing off to get that nice tail. Last thing it lets us know is our energy, which is in joules, or as you know, maybe know as kilojoules, the amount of heat energy put into the material, which can be important, especially if you're a welding engineer or the manufacturing engineer of the fluid system or gas system. You want to know how much energy is put into a material that will affect its chemical and mechanical composition of how that material acts. So we go ahead and hit save. Then we'll go ahead and hit weld. Brings me up to the weld screen. So here we're going to go ahead and zero it out. And I'm going to actually move it though to change my electrode. So here right now in the SAX 52, we have different electrode positions, or I should say different holes for different diameter electrodes based on wall thickness and diameter of the tubing you're using. I'm already set right here. So what I'm going to do is first, one side of the collets already are set in. I'm going to set in the next set of collets. Nice collet design, very easy to use. You push the button in and they snap right in and they hold into place. You do the exact opposite just to remove them. Very good collet design, very quick, very fast. We'll set those collets in. Then I'll take my tubing. Actually, that electrode's a little long, so I'm going to have to remove it first. By the way, another good rule is that if you haven't used the electrode in that weld head for a while, or you can't verify what's the last material that it's been used for, you should always change out the electrode. You don't want to cause cross-contamination of material. You don't know if the electrode's bad. Again, if you cannot verify that the electrode's good and ready for use, replace it, throw it out. A $7, $15, a $20 electrode is not worth $2,500, $3,500 rework or valve component or fittings that you'll have to throw away due to poor electrode. So set my tubing here. I know it's calling for a 65 thousandths arc gap. So I'm going to go ahead and find that arc gap here. I'll verify. That's a little larger. Here we go. And here's a nice idea. I got to give credit to the folks from SFE today. They gave me an idea. It's nice to, even if these come in metric and you're used to standard, putting some tape around the feeler gauges and just converting them over to what it is in standard, pretty good idea. So here I know I have 65 thousandths arc gap. I'm going to go ahead and set this in, place this on top. I'll do it from the back, actually. The joys of having big hands that get in the way of everything. So I set that arc gap. I see it's not too tight, but I see it's not too loose. I'm going to go ahead and home it. So now it is in the home position. And here you see that it has preset positionings for 1/16 and 3/32 electrode changing it out. So if you're using a 1/16, you would hit this, which we are, or if you're using a 3/32 electrode, it will send you to that positioning. So I'm going to go ahead and hit home. I'll hit back. And now I'm going to go over to purging. So right now what we're doing is we're setting our purge manually, where I have a nice shutoff valve. Always remember you want as much stainless steel or PFA tubing in the system when doing purging, because we're worried about, again, that ID discoloration, introducing any oxygen or moisture content, any particulates that can induce that ID discoloration, which can be tremendously important, especially in semiconductor, aerospace, oil, gas. Honestly, ID or OD discoloration can lead to corrosion of the stainless steel and how it performs and kind of bakes out, or you lose that chromium that makes stainless steel stainless. So the discoloration can be very harmful to the operation process. So I'm going to go ahead, install my purge fittings. I'm going to put them in a T. And here at OWETEC Services, we train on ID purging and OD purging very heavily. We have our own purging methods and our own purging cards that talk about pressure and flow and where to set that ID pressure and flow at, to talk about like turnover rate or evacuation rate of the moisture content or the particulates, and where to get that pressure at, because I always have a statement: flow is color, pressure is profile. So we'll go ahead and do that.
Just
so go ahead, and I'm going to set up my mag, which mag doesn't have to be PFA. It could be Tygon. It could be different tubing. I still try to go with PFA, which this is, just not to mix anything up, so that, again, don't have cause any of that discoloration. Get my gas line hooked in here. Turn on my flow. And right now, if you look at the mag gauge, I'm about 0.3 inches of water. I know, and again, we go more in depth in this with training. I'm going to be rambling off numbers of where my mag needs to be. We offer this here at OWETEC Services. We consult on this. But I know from the top of my head that the mag gauge for the pressure for half inch 65 needs to be between 1 and 1.5. So go with a happy middle. So I install my purge restrictor or my purge pin in order to restrict some of that flow. And you notice now I'm up somewhere around 3 inches of water. So I'm going to come down on my flow a bit. And I'm about 1.13 right now, which I'm okay with that. So what I'll go ahead is remove my T, but I keep everything else in line, because this is going to recreate the pressure and flow that I'm asking for during the welding process. So I'll take one side first. Usually start with this side because it comes down and it doesn't have that viewing window that's in my way. And I want to set this tubing between the wall, or that diameter, half of the electrode. So the other half of the tubing that's going to butt up next to it will also, half of it will also be over that electrode too. So it's nice and centered. You can use centering gauges too. OWETEC, we can make these, or we can give you the information on them. You can reach out to SFE if you need to, or you can make your own. A lot of folks just eye them up, especially in the field, in the industry. So I'm going to go ahead. I'm going to lock these down. And if you look here, this is a churn wheel type of locking mechanism. So if it's not tight enough, you can just churn that to get it tighter. I like things nice and snug due to my pipe fitting days. So I like everything to feel nice and secure. So that looks pretty good to me. I'm going to go ahead and take the other side, lock it in. That feels nice and secure. Then what's nice about this viewing window is I can open it up. If I have a flashlight with me, I can check on the inside, make sure that alignment is what I want to. You're worried about, again, axial alignment and angular alignment, right? We want nice, straight, square tubes that are welded together. So flip this viewing window back up, and we'll come here and we'll hit the start button, and it'll go into the welding process.
And one thing we we didn't mention right now, but there is after the facing, there is also a whole process of cleaning properly your tube to remove any type of
Yes.
grease or any moisture that that you may put on the tube during the preparation.
Yeah, as Adrien said, that's a very good point to bring up. You, especially on the application or process you're trying to achieve, you want to use like an isopropylone or an alcohol, maybe some Scotch-Brite, depending on what is allowed and what is acceptable to clean that tubing and remove any of those oils, greases, particulates, again, anything that can cause corrosion or ID discoloration to set in during the welding process. In some applications, I would be fully gowned up. I would look like I was getting ready to walk into surgery, especially in like a semiconductor application where they can't get any hairs or particulates or skin, dust, any of that on the tubing or in that application. So very good point, Adrien. And there you have it. We have a weld, right? So what I'm going to do now is I'm going to go ahead and turn off this flow. Don't need that anymore. I'm going to go ahead and remove my purge fittings. And we'll open this up and see what we got. Pretty happy with that. A little bit of discoloration on the side. This is due to me. This is not a knock on the weld head. Not to fill their head up, but they definitely deserve credit on how well that the Sachs weld head does with purging. As Adrien said, I probably should have cleaned this tubing a little bit, got some of that moisture particulates off of it, maybe let the weld head purge out a little longer. But this weld looks very nice, very consistent, really good can program for 1/2 inch 65. I would be very happy with that. Now, again, the normal way to do this is we would verify by opening it up, making sure the ID bead width is correct, and we're getting full pen and full penetration and full fusion, which we're going to do with our 1/4 inch program here in a moment. 17, where we're going to do tube to tube and tube to microfit. So go to Weld Library. I'm going to select my 1/4 tube to microfit weld procedure. I called it this, but I'm still going to use it to do tube to tube as well. So we'll go into, and I want to review it with you guys first. So here again, you see I named the program. It has the weld head, the diameter and wall thickness, and the material type and grade. Again, some of the same things that we went through and we talked about. Here, this is where I took the CAN program, which I believe asked for 8 levels, and I went with a 4-level program. This is very commonly used for like semiconductor applications, aerospace. A lot of different industries use either a 2 or 4-level program when orbital welding. We're going to talk high level about why we decided to do that and the ID bead width, but we go over this very heavily during our training classes that we provide here at OWETEC. So again, I want to reiterate that a lot of different brands, AXXAIR as well, have good CAM programs, but there's also always going to be training that's needed to do weld schedule development based on different applications, different material types, different fittings and valves that you're trying to weld and create weld procedures for. So here it goes through our tungsten selection again, a lot of the same different information that we already discussed. Here with the 4-level program, all I did was I switched from that 8-level to a 4-level program, and I brought the overall amperage down between the levels by 20%. So I know that sounds simple enough, and I know I'm explaining it high level, but there's math and algorithm that we use here at OWETEC Services that we can discuss at a later time, or we can share with you guys if you guys are interested in any consulting and training that explains when to identify coming down on that amperage or coming down on the different like down slopes or adding, subtracting levels. So this is just me verifying it's everything that I like, and it's the same program. Now I'm going to go ahead and go into weld. Here on the Sachs 200, They make it easy for the electrode change. You can just hit the button once and it takes me to the electrode change position. I hit it again. It'll take me to what's considered the homing position. It's also nice because they got buttons for stop and start and for gas flow on this weld head. So pretty nice to have, pretty convenient if you don't want to rush back to the machine. This is kind of far away from your station, guys. So here, what I would do to get that centering of this blocks, and when I mean centering, I mean axial and angular alignment. I would set my one tubing inside, or I'm sorry, I would set it across both. Lock one part of the block down, loosen the other block, then clamp it down, then retighten it. That's centering this faceplate to the other faceplate in theory. Okay. So now what we're going to do is we're going to go ahead and weld quarter 035 tube to tube. I'm going to go ahead and verify my pressure and flow. Same way I did the 1/2 inch 065.
So as you mentioned previously, we have different sizes of tungsten that we can use from 1/16 to a 3/32 on the previous welding head, which was the SATFX 52. On this smaller head, we do have smaller tungsten too that are actually 3/64 inch diameter. So that's explain why you may not see very well the tungsten right now, but that's very small tungsten, and so they are also pre-grinded. We recommend a 20-degree angle and flat tip. So same idea on this head. We do also use the same tungsten configuration.
Yes, that's another good point. The recommendation of pre-cut, pre-ground tungsten or electrodes for orbital welding is a must. It's not some way of me promoting tungsten suppliers. I promise you we don't do that. But trying to sharpen or shape or cut these smaller tungstens to an exact angle and geometry is going to be very tough. Again, $15, $7, $20 electrode is not worth the enormous amount of money it can cost you downline for destroying the process or the application that you're trying to perform. So here I set my pressure and flow. Again, we can go through this more if there's any questions in the chat, or if anybody's interested in some consulting or training or questions around that, we go over the pressure and flow. I know I have it set correctly for 1/4 inch 035. I'm going to take this out. I'm going to take my first piece of tubing, put it in the fixture block, use my centering gauge to center. I'll go ahead and turn my flow off there for a second. Kind of fighting me. So I want to get that nice tight fit up so I know it's meeting center. Then I pull that centering gauge out, butt the other tubing up to it. Take a look at my fit up and alignment, which looks pretty good. I'm fairly happy with it. Go ahead and install this into the SAC 17. Sorry guys, fighting me a little bit here. There we go. Now that's nice and seated.
Nick, can I ask you a quick question?
Yes.
So you see a little difference in the design between this head and the one before. Can you explain a little bit why those are different? What is the application for this smaller head as opposed to the other one?
Yes, absolutely. So as you notice that the SAX 52 head that we just got done doing the 1/2 inch on is a more single frame, narrower, kind of used for like infield applications, for up in rafters, for fabrication of installation of bigger, larger diameter tubing. The SAC 17 is very good for smaller applications when we're talking about microfits, VCRs, semiconductor applications, we're talking about small tool install applications. Actually, I'd like to go ahead and grab some weld assemblies. Excuse me.
All right, our cameraman is showing you the two wellheads compared. The one on the left is a SATFX 52. Nick, you got it all wrong. Sorry to say that, but the part number, you need to do a better job at the part number. Just kidding. Hey, the 52 goes up to 2-inch, right? And we have 4 different sizes, one going up to 6-inch pipe. The SAMX is a cassette head that's used more for a lot of tool install in the semiconductor, in aerospace. More smaller tubing with micro fittings, and I'll let Nick to take over. But I think it's important to specify what application, why we have different designs.
Absolutely. So what I did is I just brought some examples of that where you have to weld different microfits to VCRs that have very small tangent lengths. Sometimes these tangent lengths are 1/4-inch tube stub or tangent lengths. These cassettes allow you to reach that tangent length, and they're nice because they work as like little mini stands as well. So it keeps everything nice and eccentric, square, clamped together very well. Again, as you can see, producing something like this or something like this that would be used for like a tool install or a small gas delivery system, this could be very useful for those applications. And these applications range from not just semiconductor, but aerospace applications, nuclear applications, research applications, and so on and so forth. Any other questions?
Thank you, Nick.
Okay.
Great job.
Thank you. So what we'll go ahead and do now, and if Adrien wants to, since he's kind of next to the welder, if he wants to go ahead and hit that start button for me, just so I don't have to come through that camera again and block you guys.
You can do it from the head, Nick.
Oh, yeah. There you go. See, I'm not even using it from the head like I should. So I'm so used to the old way, you know. AXXAIR has such a new design on our weld head that I'm not used to be able to hit the start button from there. So another thing you want to be mindful of is that you don't want to ever be blocking this restrictor or this flow right here, because that will change the ID flow inside of this tubing, which can cause problems to the weld profile. So a lot of welders want to take their hand and verify and get too close, and it changes that ID pressure.
We got a question from Brent. Do you always remove the magnet halide gauge prior to welding as a best practice for any specific reason?
Yes, so we do. One of the main reasons that we do that is because, especially in training, what do welders always want to do? They're always wanting to try and finick with something or change something during the process. And one of the problems that I've always come across when you have the magnet halide gauge in line during the welding process, you're going to get some fluctuation of pressure. That's going to happen no matter what. There's no changing that. It's called differential pressure. And we can get into that later if anybody's interested in what that means or how that works. But as you're sealing up that tube, you're going to get fluctuations in pressure. And what's your first instinct? Oh, let me adjust the flow to maintain that pressure at 3 inches per water that I want. Now you're creating pressure changes inside the tube, which can change that weld profile dramatically. So this is why we don't have it in line. Now, there are plenty of applications where having it in line are useful and almost a requirement. I'm not saying that you can't do that, but for training and understanding and getting into purging and pressure flow, we try to move away from that to get out of that mindset of changing things in real time during the process. All right, now that the welding operation is done, I'll go ahead and remove all of this. Remove the fixture block. Turn the flow off. Don't want to waste that gas, right? Fill up the whole space with argon probably wouldn't be great.
And if you want, Nick, while you explain about what we can also do as far as microfit to tube, I'm going to be cutting this piece of tube so to show the inside. So
absolutely,
when I introduce to our actually new welding cassette with the microfit mounted on it, microfit collets, and so I'll be cutting the piece at that time.
And then I'll just real quickly, I'll show you the outside of the weld looks pretty good, nice consistent OD bead. As Adrien said, he's going to go over and coupon it, and then we'll show you what that looks like when he's done couponing. And as he's doing that, we'll explain and talk about AXXAIR's new cassette, which now allows you to do from tube to microfit. It has a little bit of a different design, cantilever lock design. So this is really nice for microfit applications where, again, you need to shorten that tangent length as well. So we'll go ahead and we're gonna so this is this is AXXAIR's SAMX 25C or cassette fixture block. This goes from 1/4 inch to 1 inch. Correct me if I'm wrong, Ben. This is new, so I'm still just now getting to play with it as well. This is nice for your larger size diameter tubings or fittings that you might want to weld, again, inside of one of these cassette blocks. Again, it helps a lot with axial and angular alignment, good sturdy positioning, and almost works as like, I like to refer to it, this is how I talk about it, they're like little mini pipe stands, kind of give you that nice clamping capability, good for bench work, good for different fabrication installations where alignment and fit up are very crucial.
Yeah, and I just want to add on this one, we also have thinner collets for microfits, and we also have it in water-cooled or air-cooled.
So here I'm using the microfit to tube cassette that AXXAIR just released. All I'm going to do is I'm going to set that microfit inside of that housing. I'm going to bring both of these, I call them ears, up in place. Easier if you do it on a table. And then you always want to try and bring these levers or these locks up at the same time. So you get a nice concentric clamping on here, because what can happen on any of these is that one side can lean to the other and kind of throw off the centering of that microfit, because again, it is clamping on the block or that housing of that microfit, and it's not clamping on the tube stub of it. So having a nice even level clamping on this so that you don't lift one side up from the other is important. Take some tubing. Go ahead and we don't have to worry about centering in this one either, because this is already self-centered based on where that tangent comes out to on that microfit. We'll go ahead and add our ID. Flow. We'll go ahead and put this on. There we go. Lock that in place and go ahead and hit the start button. See, I hit it on the weld head this time, guys. So.
Yeah, good, you're learning.
And then if you want, Nick, while it's welding over there, you can come and
oh yeah,
talk about our coupon.
So if we look here, some of the most important things about the ID bead coupon are a couple things. ID bead width is crucial for a couple things. You want to make sure you get complete penetration and fusion in that joint. The other thing is, a lot of the rules are you don't want to over weld or cause too much heat energy into the material. Meaning there's a rule in some of the codes and standards that go by 2T plus or minus 25%, where it's going to be 2 times the wall thickness plus or minus 25%. And then the additional rule is that the smallest or the largest measurable part cannot be smaller than 1.25 times that of the largest. So developing a weld schedule to meet that on an ID bead width is crucial. And that's when we talk about, we get more into developing the weld schedule and getting into those different levels, and where a CAN program might not just necessarily work for you, that you have to actually have some understanding around what's going on as far as in those different levels. So here you look, we have a pretty good ID bead width. Could have probably used maybe a little bit more of adjustment, but for the purpose of this webinar. But you see, we also have no ID discoloration in here too. That's where that pressure and flow are very important. We also want flat welds where we're not worried about what's called convexity and concavity, right? We want flat welds so that the gas or fluids that's traveling through these systems don't have any restriction or cause any corrosion inside the tubing.
Thank you, Nick.
All right, so now we'll come back over here, take off this microfit fixture block, and we'll take a look at our microfit to tube weld, which looks pretty good. And that's a tube to a microfit. And as you can see, very minimal ID discoloration, which is good. We're at like a straw yellow, which is pretty much acceptable across the board. Again, depending on application and requirement to your company, but pretty happy with that. So.
All right, time flies, guys. We have like 3 more minutes. So I don't know if we need to add anything to close that webinar, but I think it was really informative. Nick, is there anything else we should know, like as far as overall welding, quality, expectation? I think,
yes.
Did we name everything you wanted to cover, or do you have anything to add?
So we'll never name everything I want to cover, right? There's plenty of information around orbital welding and education around it. But I would like to leave you with this note, is that at the end of the day, running one of these machines can be quite easy as far as putting in a CAM program, hitting the start button, adding some flow, and getting ready to go. But getting into real weld schedule development and having a true understanding of the gases and the materials, the electrodes, welding different fittings, fit up, preparation, how to develop weld schedules based on different applications you're trying to meet. Training is crucial. Training around this industry has been kind of, I want to say, almost hidden for a lot of years. It hasn't been talked about. Orbital welding is becoming more prevalent, more persistent, especially with the lack of workforce and the lack of education around welding and getting things done quicker, right? Trying to compete with the other countries and get things moving much quicker. Orbital welding cuts processes in half, but it can only do that if you know how to actually operate the equipment and actually understand the process. And that's where good training and good education around it is crucial. That's why we're in business here at OWETEC Services, to provide that education and training, not only in orbital welding, but manual wire feed welding, robotic welding, manual welding. And we're very, very honored to be able to work with the different manufacturing brands that believe in the education of welders that are going to be our future, right? That's why we all get together to do these, because at the end of the day, our end goal is the user and educating that user for our future workforce. So thank you, guys. That would be my last statement. Yeah. And if there's any questions, please ask.
Yeah, I wanted to add something really quick. I think it's always there's misconception about orbital welding where we think it's just reserved to pretty high-tech industries and really sophisticated welding. It's not necessarily the case. There's a lot of companies that do welding manually that turn to us because we can simplify the process. I'm thinking about some, for example, right now, cryogenic application where they have a lot of Schedule 10 to weld, and we can actually fuse it with these close heads where they used to have to weld it by hand with wire, and we can save their time, have their welder focus on like more sophisticated tasks, and let the orbital welder do more like the simple welds, make them actually simpler. Like you can see on the right hand side of the frame of the screen, Schedule 10 welded fusion with the close head. So there's a lot of applications that we cover with those machines, not necessarily semiconductor, aerospace, pharmaceutical, nuclear. There's actually a lot of other industry that it could be adapted to, and that's something I wanted to use. We actually use this webinar with the semiconductor in sites, because we know it's something that's being talked about right now a lot. But actually, there's a lot of other application beside the semiconductor application, of course. We could do those elbows too, so short radius elbows. They come with a bevel. So we take the bevel off with a facing tool or with the end prep equipment. So we take that bevel off, face it to a square butt, and then we put a tube with a square butt too, and we just do a fusion weld, and we consume the whole tube in one pass without filler wire, and it makes a beautiful weld. But yeah, thank you guys again. OWETEC, great job. Nick, great job on the presentation.
Thank you, guys.
You must be thirsty by now. and thanks, Adrien, also for helping. Thanks, Ziad.
Yeah, my pleasure.
For shadowing everything and helping out. And again, we'll see you out there, guys. Be safe and take care, and feel free to reach out.
Thank you.
Hung around.